today we're taking a seriously exciting journey straight into the brain of modern cellular networks. We're going to solve one of the absolute most fascinating challenges in telecommunications right now. We're talking about that cutting-edge sweet spot where artificial intelligence, 5G networks, and autonomous drones all crash together.
Drone connectivity problem, high speeds, 3D movement, and the ping pong effect.
You see, drones are fundamentally way harder to keep connected than that cell phone sitting in your pocket. Unlike cars, which basically just travel in 2 dimensions, drones have these complex 3D movement patterns, and they're moving at incredibly high speeds. But actually, the biggest issue? It's the altitude. Up at 30 meters, drones have a super high line of sight probability. What that means is they can suddenly see multiple cellular base stations all at once, just because there aren't any buildings blocking the signals. So instead of getting one clear, strong connection, the drone gets completely bombarded with interference from all the neighboring cell towers.
And because of all that interference, traditional reactive handovers just completely fail. Traditional networks rely on what we call greedy algorithms. Basically, they wait until a signal drops below a certain threshold, they kind of panic, and then instantaneously switch you to the nearest strong tower. Well, for a fast-moving drone, this causes what engineers call the ping pong effect. The drone rapidly bounces its connection back and forth between multiple towers as it flies. That drastically increases signaling overhead on the network, and ultimately it leads to radio link failures. And in the real world, a radio link failure means the drone loses its navigational link, mission over.
This brings us to O-RAN, or the Open Radio Access Network. O-RAN is an open, virtualized, and fully interoperable mobile network architecture. Basically, by breaking down traditional, closed-off cellular towers into programmable, software-driven components, O-RAN sets up the exact foundational environment we need for AI to step in and handle all this complex network management.
But how does it anticipate that? Well, think about it. Many commercial drone missions, like package deliveries or infrastructure inspections, they have pre-filed, predetermined flight plans. The DDQNX app securely ingests those flight paths right from the drone traffic management system. Since it knows exactly where the drone is heading, the AI can look ahead, anticipate the network conditions along that specific 3D route, and proactively switch towers at the precise optimal moment. This completely bypasses those reactive, greedy algorithms and absolutely kills that nasty ping pong effect we talked about earlier.
And this brilliantly illustrates a key quote from the source research. The integration of AI/ML capabilities within O-RAN represents a fundamental shift from traditional rule-based network management to intelligent adaptive optimization. The entire telecom industry is fundamentally shifting away from being rigid and reactive to becoming fluid, intelligent,